Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, in today's video, after a video that I've recorded explaining all the concept under energy and change, and now we're gonna look at a few multiple choice questions and a few exam questions, structured questions. Okay. So, without wasting any further time, let's just dive into it. Now it said so 1.3 says the minimum energy the minimum energy the minimum amount of energy needed for a chemical reaction to start is called. Now this is your definitions. Okay, this is you just knowing your definitions. Let me try to zoom that out for you. Yes, so you know that the minimum energy needed for a chemical reaction to start is called what? Activation energy. So where is that? Yes. So remember, catalyst is it just speed up the reaction. Heat of energy, it is an energy that is released or absorbed in a reaction. Bond of energy, no. Okay, so A is the correct answer. 1.1. Consider the definition given below. The higher energy transition state between the product and reactant. This is the definition of, remember, the higher transition energy, the higher energy of unstable transition state between product and reactant. It is what? Activation energy. So activated complex. So the most correct answer is what? D. This is you knowing your definitions. Okay, yes. Definitions can be stated in different ways, but use the definition that your teacher gives you in a classroom. Okay, yes. Consider the potential energy graph for the hypothetical reaction. Okay. So can we see now this is the energy of our reactants? This is the energy of our reactants. Energy, high energy of the activated complex. So we know if we say from here to here, Z minus Y, it is what? EA. Okay. So we know this is energy of the reactants, this is energy of the product. So I know from here to here, sorry, to here, this is my change in H. So Y minus X, it is my what? My change in H. Okay. For the forward reaction. Okay. For the reverse, if they want a reverse, this will be my EA. Then my change in H will be the same. So now, yes. Now let's see. The heat of the reaction is given by what? The heat of the reaction. Let's see. Z minus Y. Z minus Y, no. X minus Y. X minus Y. X minus Y can be true because this is energy of the product minus energy of the reactant. So basically for us here, the energy, should be energy of the product, which is X minus Y. Okay, can you see this is exothermic? So this might be the correct answer. Let's just do a question mark. Y minus X. Can you see now the difference between this is X minus Y, this is Y minus X? The difference between Y minus X is that from Y, it is the energy of the reactants minus the energy of the products. And we know when our change in H formula says it is the energy of the products minus the energy of the reactants. So this one is not correct. Y minus Z. Y minus Z. No, this is the not. So now the correct answer is B. So when you want change in H, it is always energy of the product minus energy of the reactants. Okay, yes. Do not confuse that. 1.4, another 1.4. It says now the diagram illustrates the change in the potential energy. Okay, illustrate the change in the potential energy of of the reaction. So now we have x squared, 3y squared, that one. This is a hypothetical reaction. Okay. So now the question says how much change in H per mole of XY3 is formed. How much energy, change in energy per mole of what? Of a of XY3 is formed. So now we want to check. This is the energy of the product, right? We know this is the energy of the reactant. Can you see these are the reactant? Energy of the reactant. This is energy of the product. Sorry, of the product. But now we know the energy If this is a, can you see this is a graph of an exothermic reaction? So we know for an exothermic reaction, the energy should be less than zero. Should be less than zero. So now if from here to here, from here to here, it is 92. But remember, when we went from the product to the reactant, so it will be that this number, but with a negative sign, because now changing H is less than zero. You can be tempted to say positive 92, but it is, this one is not. This one is not. Okay. You might be tempted to say positive 92, but remember, this is a graph of an exothermic reaction. They did not tell you, but the graph should be able to analyze that. Okay, the energy of the product is less than the energy of the reactant, so the most answer, it will be B. 1.5. Consider the hypothetical reaction A plus B forming that change in H is less than zero. So this is an exothermic reaction. Okay? So now the activation energy EA for this reaction, it is this one. I like to draw it. So I'm told this is is less than zero here. So I'm expecting a graph that's more or less like that. Okay. I'm told what? What is it that I'm told? I'm told that the activation energy of this reaction, it is 100. So from here to there, from here to there, it is 100. So I might say this is, okay, let me, the difference, remember, from the activated complex to that. So I might say this is 100. So if this is 100, I have to put this energy of the reactant as 0. Remember, it is possible that the energy of the product, it becomes negative. Okay. So, okay. Or I can say, so that I can say this is 200 and this is 100, so that it gives me the difference of 100. Okay, now this is for the forward. Remember, everything that you are given here, you are given an information for the forward. The activation energy for this reaction, it is 100. It is for the forward. Now they say to you, for reverse reaction, how? Okay, for reverse reaction, let's look at the reverse reaction. This is EA for the reverse reaction. Can we see that? EA, and it is greater than, let me just say, for the reverse. And I want you to see something. The blue color, it is there. This color. Okay. This is for the forward. And then this is for the reverse. Okay. The color is for the reverse. This is the what? The change in age. Oh, sorry. Let me do this. From here, this is, okay, energies. Okay. So I might say this is energy of the forward reaction. Okay. It is change in age. But remember, similarly for the change in for the reverse also, it is also the same value. Just that what will differ is the sign. Okay, for the blue one, which is the exothermic reaction, the change in age will be negative. For the reverse, which is red, which is like this, the change in age will be positive. Okay. Remember, I told you if for the forward it is changing H is less than 0. This information is for the forward. Therefore, it means for the reverse, our change in H will be greater than 0. So now let's answer. For the reverse reaction, EA is equal to 100. Can we see that for the reverse reaction, is EA equal to 100? No, the EA will be greater from here to whatever this value is here. Let's say this value here. Let's just put the value here and say it is maybe something like, let's say it is 0. Can you see that for the EA it is 200 minus 0? So it will be something like 200. Okay, so it is not equal. EA is greater than 100. Indeed, it is greater. Okay, it is greater. This one, it is the correct one. EA is less than, it cannot be less. Can you see now? It is longer. Okay, EA and change in H are equal. Okay, for the reverse, no. For the forward, we don't know yet. Hence, I do not want to assign a value here, okay? Because it makes something like I assume something. But for the EA, I want you to see it is greater than 100. So it's going to be 200 minus whatever the value is here. It is greater, okay? EA is equal to the change in H. Can you see now the change in H is here and the EA it is there. So it cannot be equal. EA it is greater. So the most correct answer it is B. 1.5, the last one maybe. Oh, okay, the second last one. A potential energy diagram can be used to show the activation energy and the heat of the reaction, which is a change in enthalpy. Which one of the following combination of values for EA and H cannot be obtained for any reaction? Now let's draw for the forward. So for the exothermic and compare. Exothermic, it will be something like this. For endothermic, it will be something like, okay, let me redraw that. It will be something like that. So which one cannot be obtained? EA being 50 and change in H being less than negative 100. Let's see. Let's see. If EA was to be 50 here, so it means here will be 50 and say here it is 0. Okay. This is our EA. Then if this is 0 and this is somewhere here, change in H can be something like, let's say here it is negative 100. So it can be, okay, I want you to see something. EA can be 50, okay? And now change in H can be negative 100, okay? Yes. But now in this case, let's look, we are going to look at both scenarios. Again, let's use the same values, 50. And now for this one, it can be, you can say it is 0 and this is negative 100. I want us to see something. Okay, EA can be 50 also here. Can you see? EA, it is 50. Okay, EA, it is 50, can be 50. And now, change in H can be positive 100. Let's see, energy of the product. It is 0. Can you see energy change in H? It is the energy of the product, which is 0 minus energy of the reactant, which is minus 100. Can you see this can give us positive 100? So this one is possible. Okay, this one can be, okay. C, EA can be 100. Okay, EA can be 100. Okay, here I did a wrong EA. This EA here, it's supposed to be from here to there. Okay, and now our change in H is from there to there. So for the forward, okay, let me erase this and restart it. EA here, it can not be 50. Okay, because it is 50 minus this one. Okay, and I want you to check something for the forward direction, for not forward direction, for the endothermic reaction, the activation energy will always be greater than the change in H. Can you see that? Yes, here the activation energy, it is 150, but the change in H, it is how much? It is 100. So this one, it is wrong. This one, EA cannot be less than this one, so this one is wrong. Okay, C, EA is greater than change in H. This one I can accept. Then EA is greater than this one. Again, this one I can accept. One thing you have to note is that EA is always greater than, not always, for this one, for this reaction, okay? For the forward reaction, EA, not for the forward reaction, for the endothermic reaction, EA is always greater than change in H, okay? For this one. Similarly, even for this one also, even for this one also, actually for both reactions, there's no way EA will be greater than EA will be less than change in H. This is what you have to take note of. Here, EA is greater than this one, yes. Here, is it greater? No. Can you see? Yes. So if you know that fundamental theory that I just explained now, you will be fine. EA is always greater than change in H. I move on. The last one, the potential energy diagram for the following reversible hypothetical reaction, it is given. Okay. Now I want you to see something from R to P. From R to P, this is the activation energy. R to P, it is the activation energy for the forward. Let me just say for the activation energy for the forward, okay? because it's from the activated complex to the reactant. Now from Q, which is the energy of the product, to P, Q to P, it is the change in H for the forward, and it is greater than 0. Q to P again. Then another thing for the reverse it will be what? RQ. RQ, it is any activation energy for the reverse. And now similarly, these are our products. So if for the reverse, remember we just reverse the reaction. So this will be our products. For the reverse, this will be our, oh sorry, for the reverse, this will be our reactants, then ending at our product. So P minus Q, it will be the change in H for the reverse, which is less than 0. Let's now answer the question. Consider the following statement regarding the energy, the energy diagram. Change in H for the forward direction is positive. Change in H for the forward direction. Can you see that? Change in H for the forward direction, it is endothermic. The forward direction is endothermic, so the change in H is greater than 0. Yes, it's positive indeed. This one is correct. Can we also indicated for the forward it is greater than 0. Okay. Catalyst would lower PQ. PQ. Can you see that PQ, it is the change in H? So remember, what does the catalyst do? It only changes the activation energy. So in this case, it is wrong. Catalyst does not affect PQ, which is our change in H. It's wrong. Reversible reaction, it is exothermic indeed, because why? The forward reaction, it is endo, so it means the reverse reaction will be exo. So now this one is correct. Reversible reaction, it is exo. So which one of the statement is or are true? So now 1 and 3, 1 and 3, 1 and 3, 1 and 3. So C is the most correct answer. Yes. So now let's move on to one of the questions faster. The graph of the potential energy versus the course of the reaction for a certain chemical reaction is shown below. So now here we have from x minus x. Can you see from this one minus w, x minus w, it is the activation energy. Okay, then what? From the product to the reactant, which is changing y, which is y. This one is our change in H. Okay, then yes. Okay, cool. Now we are in a position of answering why it is changing H, and it is greater than 0 because this is an endothermic reaction. Even though they do not tell you, it is endothermic reaction. Why? Because the product, energy of the product here is greater than the energy of the reactant. So now 5.2.1, write down the letter that represents each of the following. Activation energy, I said it is X minus W, but can you see it is already represented by Z? Okay, yes. So I can say now Z. Change in H, it is Y. Can you see that? Yes. Easy marks here. Easy stuff. So this question I cut it because some of the questions there for 5.1 were not that is as that was yo way. The other 5 marks is not assessed, okay, for grade 11. So I just want to make this a grade 11 topic. Even if you are doing grade 12, it's fine. We'll encounter questions for grade 12, okay? Yes, but it is necessary for you to watch this. Calculate the activation energy. Remember, the activation energy, it is for the activated complex to the energy of the product of the reactant. So now our EA is just there is no formula for that one. EA, energy of the activated complex, it is 250 minus energy of the reactant, it is 25. So our answer is 225. But what the units are very important. Kilojoules. Done. Very easy, straightforward. Okay. Then let's move on to the other one quickly. The following reaction between ammonia and oxygen places in a closed system. So it means it is a reversible reaction, but now we are not sure that. Okay, but always in grade 12 you'll always encounter this. Okay, but in grade 11 it's fine. At a constant pressure and temperature, okay, sharp. Now, you see this is the activation energy. Okay, we are told this is changing H. We are given this is the exothermic, so we know our change in H will be less than 0. Okay, because this is the exothermic reaction. Okay, then our EA like that, yes. Then, okay, now let's answer the question. Define the term activation energy. Remember, the activation energy, it is the minimum energy required for a chemical reaction to start, okay, or to occur. Give a reason why this reaction is exothermic. Why? Because now you can say change in H is less than 0 because you can see, or you can say energy of the product in full, right? Product in full is less than any. Sorry, let me do this. Or you can say energy of product is less than energy of reactants. Any of the two is accepted. Calculate the heat of the reaction. They had an error in typing here. The heat of the reaction, they want you to calculate change in H. Remember, how do you calculate change in H? Change in H, it is energy of the what? Of the product minus energy of the reactants. You do not necessarily need to write down the formula. Okay, it's fine if you do not. Energy of the product is how much, how our product, remember these are our reactants. These are our reactants, these are our products. It is how much? 183.3 minus energy of the reactants, 400. So now can you see now our change in enthalpy? It is less than 0. 183.3 minus 400 thereof, you get something like negative 216.7 watt kilojoule per mole. It is very important to include SI unit. For substituting, this is 2 marks, then this is 1 mark. Formula, if you do not write it, it's still fine. It's just a reminder, okay? Now, redraw the graph and indicate with a dotted line the effect of a catalyst. You'll redraw your graph, okay, exactly as it is. You do not need to indicate this, okay? But what you have to indicate is that here, remember what does a catalyst do? It lowers the activation energy. So you can do that. This is what you have drawn. Remember, you will be drawing your new graph again. You do not need to show your values. You can say, okay, just indicate this is the cause of reaction, this is the energy, okay, in whatever unit. Then you do what? You say it will do what? It will affect this in this way. Then you are done. Then you are done, okay. Then probably the last one, yes, the last question. The balanced equation now for the reaction of carbon with steam is as follows. Carbon, steam, it forms carbon monoxide and all the stuff. The graph not drawn to scale represents the change in what, blah, 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 blah. Okay, so can you see this is endothermic? Change in H is greater than 0. Why am I saying it is endothermic? This is the energy of the reactants and the energy of the products. Can you see now the products are greater than the reactants, so it will result in a positive what? In a positive change in H. Change in H here. This is EA. EEA. Define the term heat of a reaction. So heat of a reaction, I did not define it in any of this. You can say it is defined as the energy released or absorbed in a chemical reaction. Why? Because now remember, changing H, if it is greater than 0, energy is absorbed, it is less than 0, energy is released. Is the reaction endothermic or exothermic? So we know it is endothermic. We just explained that. Why? You can say changing H is greater than 0, or you can say energy of the product is greater than energy of the reactants. Okay, yes. Use the information on the graph and write down the value of activation energy, 7.3.1. Activation energy, remember it is an energy from the activated complex to the reactants. So activated complex to the reactants, which is this 593 minus what? Minus 49. This gives us something like how much? Let me confirm that. 593 minus 49, something like 544. But what units are very important? Kilojoule per mole. Okay, kilojoule per mole. Then 7.3.2, the last question. Heat of reaction. Remember, heat of reaction, it is changing H. Remember, I said to you, formula is not important, but just to remember, it is the product minus the energy of the reactants. Okay, how much is that? How much is that energy of the product? Which are our product? Here our product, it is 180 minus our reactant, it is 49. 180 minus 49, 49, it is something like 131 kilojoule per mole. For easy 2 marks, substitution and answer, substitution and answer. Okay. So this was fairly easy. Now this topic is very easy, so you need to master it. Okay. So thank you very much, folks, for being with me now on this video day off. So yes, if you enjoyed the video, please give it a thumbs up and kindly subscribe if you haven't done so. And yes, I hope you are doing well for the exam preparations if you are currently preparing for exam, or if you are just enhancing your knowledge on this topic. So yes, all the best. If you see any mistake, if you encounter any mistake, or you need clarity on something, just leave your question on the comment section. I'll attend it as soon as possible. Thank you.